Hi, welcome to mathematics. In this video, we want to solve for m in 2 plus m raised to power 4 equals 16. Let's see solution. We have 2 plus m raised to power 4 equals 16. But if you look at this, you will observe that it has a degree 4, so which make it a quantic equation, and therefore we will be obtaining 4 solutions for the equation. So let's go. So we have this equation, so and this will become 2 plus m raised to power 4 equals 2 raised to power 16 can be expressed as 2 raised to power 4, right? So then we can transfer this 2 raised to power 4 to this side. So we have 2 plus m raised to power 4 minus 2 raised to power 4 equals 0. So from here, let's recall that wherever we have a raised to power x, then raised to power y. This is equals a raised to power xy. This is the power law of indices. When number which is raised to a certain power is again raised to another power, the powers are multiplied, and that's what we do here. Applying this to the above expression, we will have from bracket 2 plus m square, right? So then let it have another square. Minus, also express this as 2 raised to power 2, then let it have square equals 0. So from here, if you look at this, you see that we now have difference of 2 square, such that when we have a square minus b square, this is equals a plus b, then a minus b, right? So when we apply this to this, we will have bracket, we have 2 plus m square, right, plus 2 raised to power 2. You have it like this, then multiply by again. So this one will be for subtraction, square minus 2 square. This is equal 0. So we will have this equals 0 and this equals 0. So we have 2 plus m raised to power 2 plus 2 raised to power 2 equals 0, or 2 plus m square, no, so 2 plus m square minus 2 raised to power 2 equals 0. So now let's take this one as the first case, and let's take this as second case. So let's first deal with the first case, so which is the one here. So we have 2 plus m square plus 2 square equals 0. So by letting us know that wherever we have this identity a plus b square, this is equals a square plus b square plus 2ab. So if you apply this to the above, we will have 2 square plus m square plus 2 times 2 times m plus 2 square. This is equals 0. So and simplifying this, we have 2 square will give us 4 plus m square plus 2 times 2 will give us 4 times m will give us 4m plus 2 square will give us 4 equals 0, right? So we have m square plus 4m plus, this is 4, this is 4. 4 plus 4 will give us 8 equals 0. And if you observe, you will see that this is a quadratic equation. this is a quadratic equation. So, and to solve that, let's use a quadratic formula. From here, we have our a coefficient of m squared, that is 1. Our b coefficient of m is 4. And our c constant, which is m. So, using quadratic formula, we are going to use m equals minus b plus or minus square root of b square minus 4ac divided by 2a. Now we'll have m equals minus, what's our b? 4 minus 4 plus or minus square root of, that is b is 4 square minus 4 times 1 times 8 divided by 2 times 1, right? So now we have m equals minus 4 plus or minus square root of 4 square will give us 16 minus 4 times 1, that is 4 times 8, that will give us 32 divided by 2 times 1 will give us 2. So we have m equals minus 4 plus or minus square root of 16 minus 32, that is minus 16 divided by 2. Then we have m equals minus 4 plus or minus, we have square root of 6 minus square root of, sorry, we have square root of 16 times square root of minus 1 divided by 2. But recall that our I, so which is iota, equal to square root of minus 1, and we can substitute this for I into this. So we have m equals minus 4 plus or minus square root of 16 will give us 4, then times square root of minus 1 is I, so divided by 2. So we have m equals minus 4 plus or minus 4 times I will give us 4i divided by 2. So we have m, we can factorize 2 out here, so we have 2, then what will be left here, we have minus 2 plus or minus 2i divided by 2. 2, we cancel these 2, we have m equals minus 2 plus or minus 2i. And from this, you see that we have m1 equals minus 2 plus 2i, and you can say m2 equals minus 2 minus 2i. So these two, we can call them complex solutions. So, but let's remember, this is the first case we just dealt with. So for the second case, for second case, remember the second case is 2 plus m raised to the power 2 minus 2 square equals 0. Find the identity for this. So we recall that wherever we have a plus b square, this is equal, like I said earlier, a square plus b square plus 2ab. So applying it, we have 2 square, right, plus m square plus 2 times m, right, minus, then we have 2 raised to the power 2, and that gives us 4 equals 0. Moving further, we will have 4 here plus m square plus 2 times 2 will give us 4 times m will give us 4m minus 4 equals 0. So you notice that this will cancel this, plus 4 will cancel minus 4. So we left with m square plus 4m equals 0. And from here, you can actually factorize them out here. We have m, then what we left here, m plus 4 equals 0. So here we have m equals 0, or m plus 4 equals 0. So we have, for this, we have m equals 0, or if you transfer this plus 4 here, we have m equals minus 4. So you can just name this. We've gotten our m1, m2. You cannot name this m3, and this will be m4. So in total, so we have our m1. We've gotten our m1 to be. So, but don't forget that these two will be, they will become what? Real solution. So the earlier one we got is they are complex solution. You can say m1 is minus 2 plus 2i, then m2 equals minus 2 minus 2i, and m3, so what is our real solution, equals 0, and m4 equals minus 4. So this is our answer. Thank you for watching. I hope you enjoyed this video. Kindly like and leave a comment, and don't forget to share with your friends and network. Do well to also subscribe to my channel to stay updated on my next video. Bye.